To fly along a required flight path, the four forces on the aircraft have to be precisely manipulated. Every movement along these three axes should be controlled too. This cannot be achieved with the engine and wings alone. It is for this precise maneuvering that we have what we call control surfaces on the wings and the tail assembly on the aircraft. Control surfaces are movable segments that work on the same principle as lift. They create a difference in pressure on the tail or wings that they are attached to, and this difference in pressure forces the aircraft to move in the desired direction. Essentially, as their name suggests, control surfaces provide additional surfaces that can control the orientation of the aircraft. How does a control surface do that? Let's start with the tail assembly or empennage of the aircraft. An aircraft has what looks like a fin and rear wings at its tail end. The fin is called vertical stabilizer and the rear surfaces are called horizontal stabilizers. Any erratic movement of the nose can change the flight course, and it is for preventing this that the tail assembly is provided. It ensures that the nose of the aircraft stays in line with the direction of motion and makes the aircraft stable. The first among control surfaces is the rudder, which is a panel attached to the vertical stabilizer. When the nose of the aircraft develops a tendency to move right or left, the rudder is employed to bring the nose in line again. Rudder thus controls yaw. The rudder is mostly used during takeoff and landings to keep the nose of the aircraft in the center line of the runway and can be manipulated with foot pedals in the cockpit. The rudder also plays a major role in helping an aircraft execute a balanced turn. This can be achieved using controlled yaw movement. The second set of control surfaces are elevators, and these are panels attached to the two horizontal stabilizers. As the name implies, elevators are used to elevate the nose, that is, they control the pitch of the aircraft. Elevators are used during climb and descent. In earlier aircraft, they were manipulated using the control column and wheel. Newer aircraft uses fly-by-wire mechanism in which control inputs are converted to electronic signals which moves the control surfaces. For this, some of them use side stick controllers instead of control wheels. The side stick controllers can be used to manipulate control surfaces. Next, let's check out control surfaces on the wings. First, we have ailerons, which are panels built into the trailing edge of the wings. When lowered, it increases the surface area and angle of attack on the wing, thereby increasing lift. When raised, it decreases the lift on the wing. These are the panels that help an aircraft roll right or left. When an aircraft is on a steady path, the lift on both wings are even. To roll right, the aileron on the right wing is raised, while the aileron on the left wing is lowered. This action creates a difference in lift between the wings, with higher lift on the left wing and lower lift on the right wing. This difference causes the aircraft to roll towards the right. To roll to the left, the aileron on the left wing is raised and that on the right is lowered. Ailerons can be manipulated by turning the control wheel in older aircraft or with the side stick controls in newer cockpits.